Lesson 6-3, solving systems by elimination, and we're going to use the addition method all of the time. You're going to need notebook pages 82 and 83. There's plenty of space on 83 for the examples we're going to do. Elimination is the third method that we're going to use to solve systems of equations. And just like with substitution, our goal here is to get one equation with one variable. And when we do this by elimination, we add the two equations in the system together. Now this feels kind of like magic, like what you could just add the two equations together and then you can solve for one variable that way? Yeah, actually you can. And some equations are beautifully, perfectly set up for this already, and then there's others we have to do a little tweaking with algebra to put them into that form. Okay, so this page is already in your Know It notes, so you don't have to write it all down. This is just a really nice chart where you can see when are you going to want to use which method. Now, personally, graphing I don't find to be especially efficient. So graphing is really for me only if both equations are already solved for y. The numbers are really small and it seems like the answer is going to be integers. Maybe I'll graph it. Substitution is a good option if both equations are solved for the same variable, which is the second example here, or you already have one equation solved for one variable like we do here. It's pretty easy to plug it right in. But I will say that my very favorite is elimination because it just feels so slick and relatively easy. To me, it feels easier even than substitution. So those are the three methods. We'll talk about them more in class about how you choose which one, because choosing wisely means that you can be more efficient and get your work done faster and be right more often. Now we get to another page here of a whole bunch of writing. So I am going to talk through it this time just because I feel like last time on 6-2 I didn't. I'm thinking maybe that was a bad choice. So I'm going to talk through these. You can write and listen at the same time. So the first step is you're going to write the system down so that like terms are aligned. And what I mean by that is the x's are on top of each other and the y's are on top of each other. And generally in this kind of process, elimination, we want them on the same side of the equal sign, so we'd have a number on the other side. Step 2, we're going to eliminate one of the variables. Okay, we're going to look at the coefficients. We're going to turn it into what we call a perfect situation. Now that's just kind of my little nickname for it. That's so that something, when you go to add these together, whatever the numbers happen to be here, let's just fill in a few. Right? When you add these together, we want something to cancel out. That's the goal here. We're getting a variable to drop out. Okay. So then step 3, solve for that variable not eliminated in step 2. So we would solve for y. I didn't make up a very nice problem. It would be 22 over 8, which simplifies to 11 over 4. That would be us solving for that variable. And then just like with substitution, step 4 is exactly the same as it was in substitution. We take that value of y, we plug it back into one equation or the other to find the other variable. Because just like before, we need an ordered pair as our answer. And that's step 5. Write your answer as an ordered pair, check it, make sure it actually works. Should check it in the equation you didn't already use to find the other variable. So whatever you didn't use in step 4, you should check that answer with step 5. If you need more time to write things down, pause the video, and otherwise we're going to move on and try a few. Okay, so we're not going to use the boxes on page 83 at all. We might go back and use them in class, but right now we're just going to focus not on what ones we could do with which method. Right? We're just going to focus on learning elimination. So on page 83, write this example down, and let's talk through it. Now notice this is what I call a perfect situation. It's already all set up for you. And what I mean by that is when we go to add these together, remember that's the magic that happens here, we just add them together like they were regular old numbers, then something immediately cancels out in terms of the variables. So you can see that the negative 4y and the positive 4y drop out, and we just add. This is 3x and 1x makes 4x. There's nothing there. And 10 plus negative 2 is 8. Oh my God, how simple is that? Don't you love this? I love this method. I'm so excited. I'm standing here in my classroom all by myself, and I'm so happy to teach you this. Okay? Divide both sides by 4, x equals 2. Yes, it is that easy. Take your 2, plug it back into whichever equation seems simpler. I'm going with equation 2. So 2 plus 4y equals negative 2. Subtract 2 from each side, and we get 4y equals negative 4. So y equals negative 1. So it looks like our answer should be 2 comma negative 1. Let's double check it in the other equation, the first equation. 3 times 2 minus 4 times negative 1 should equal 10. This is my check. I don't want to lose anybody. And that's 6 minus negative 4, which is 10. So I am right. Okay. Now it's always the super easiest when the equations are already beautiful for you. Now we're going to look at one where it's not quite so beautiful. Okay. Now in this example, it's close to perfect. So write the example down on page 83 again in your notes. I think we're going to do 4 examples. I want to see all 4 tomorrow. Now this, it would be perfect because we have 2x and 2x, but they don't cancel out right now. They add up to 4x. So if we just made one of those negative, we'd be in business. But we can't just make that negative. Really, we're going to multiply the whole equation by negative 1. And when we do that, so I'm going to write it over here. I'll show you the shortcut way to jot it down in just a second. Okay. Now my second equation is, let's rewrite the first one. Negative 2x, and that was minus, so plus, now negative 5 times negative 1 is positive 5y equals negative 13. Do you see how the signs on every single term changed? So the shortcut way would be just to write the negative in front of the 2x, the negative in front of the 5, or negative of negative would become positive 5y, and then a negative sign in front of the 13. So it's fine to just adjust the original problem. You don't have to rewrite it all. Now I can add them together and watch the magic. 2x and negative 2x is gone. Y plus 5y makes 6y's. Negative 5, remember we're adding, plus negative 13 makes negative 18. Does it always turn into a beautiful one-step equation? It does. So y equals negative 3. I guess it could turn into a fraction. So the answer might not be lovely, but it does always turn into a one-step division, multiplication, division kind of equation. Now we take our negative 3, we plug it back into whichever equation seems simpler. I'm thinking equation 1 seems simpler. So 2x plus negative 3 in place of y equals negative 5. And add 3 to both sides, and we get 2x equals negative 2. So x equals negative 1. So it looks like the answer should be negative 1, negative 3. Check it in the other equation that we didn't already use. 2 times negative 1 plus 5 plus negative 5 times negative 3 is supposed to equal 13. And 2 times negative 1 is negative 2. Plus negative 5 times negative 3 is 15. And that does make 13. So I know my answer is correct. Moving on. They get harder every time. Hang in there. So those are the kind we're going to work on Friday. Those kind of easier version. Now we're getting more into what we're going to talk about on Monday. But we're going to do it now. Get the notes out of the way so it can percolate in the back of your mind all weekend. The system is x plus 2y equals 11 and negative 3x plus y equals negative 5. And even if I make something negative here, nothing is going to drop out. I need coefficients that are the same. So if I had 3x and negative 3x, that would be a good thing. Or if I had 2y and negative 2y, that would be a good thing. But it doesn't look like that right now. But that's okay, because I can do whatever I want to every single equation that's out there as long as I do it to both sides, as long as it stays in balance. Which variable you choose to eliminate is totally up to you. So Maybe we'll even do it twice right now. So let's do it the first time with multiplying this whole first equation by 3, because then I'll have 3 x's. And I'm just going to rewrite it just below here. And I get 3x plus 6y, don't forget to distribute, equals 33. Now it's perfect. -3 and +3 add up to nothing. 6y and 1y makes 7y. 33 plus -5 is 28. And divide both sides by 7, y equals 4. Solve for x, and let's pick the first equation because that looks nicer. Use the original equation. X plus 2 times 4 equals 11. X plus 8 equals 11. So x equals 3. So it looks like our solution should be 3, 4. Double check it in the second equation that we didn't use. -3 times 3 plus y is 4 is supposed to equal -5. -9 plus 4 equals -5, and that is true. Okay, we know that that works, so 3, 4 is our answer. I'm going to change pen colors, and you don't have to write this way down, but I just want you to see that it works. This is a big or. You would never do both. You would do one or the other. My two equations were x plus 2y equals 11 and -3x plus y equals -5. So if I didn't want to get rid of the x's and I instead wanted to get rid of the y's, what I would do is I would multiply the second equation by actually -2, because they're both positive, so we need the 2 to be negative. And I would then get 6x plus -2y equals, this 5 is negative also, positive 10. And my first equation was x plus 2y equals 11. I'm going to add them together, and I get 7x's plus nothing, because those drop out, equal 21. So x equals 3. And then I would plug my x value back in, and I would find my y value, and I would be done. Now remember, you don't need to do elimination to find both y and to find x. You could, but that would be the long way, right? After you find one variable, you just plug it back in to find the other one, just like you do in substitution. Right? And you definitely don't need to do both ways, just pick one way. All right, so that's example 3. That was a little harder because we had to multiply one equation by something to make something disappear. And remember, that's okay because we're multiplying both sides of the equation by that number, so it's still equivalent. It still has the same y-intercept. It still has the same slope. It's still the same line. That's why it's legal. Okay, here's our last example for this video. I will save the word problems for in class on Monday. Write the system down. -5x plus 2y equals 32 and 2x plus 3y equals 10. Okay. Now you'll see up here at the top in blue it says you need to multiply both equations to get one variable to cancel out. You could, I guess technically, you could multiply 2 by 2.5 to get 5. That would be okay, so you could do that. But most of the time, if you see numbers that are not multiples of each other, so 2 and 5, not strictly speaking multiples of each other, and neither are 2 and 3, then we're going to need to multiply both of them, right, to get that kind of the least common multiple of them that'll cancel out. And so in this case, you can either get rid of the x's or you can get rid of the y's. It's your choice. Pick whichever one seems easier. In this case, they both seem about the same. I'm going to pick the x's just because one's already negative and one's already positive. So then the least common multiple of 2 and 5 is 10. So what I'm trying to get here is I'm trying to get -10x and +10x because those are going to cancel out. That means I'm going to multiply the second equation by 5, and I'm going to multiply the first equation by 2, and that's going to give me my 10x and -10x, and then I'm going to distribute it. So taking the 2 and distributing, I get 2 times -5x is the -10, plus 2 times 2y is 4y equals 64 from 32 times 2. Then the second equation, I already have my 10x. 5 times 3y is 15y, and that's going to equal 50. So these two equations are equivalent. If we graph them, they would be the exact same lines as the first set of lines, right on top of them. And now, we get to the magic part. 10x and negative 10x cancel. 4 and 15 make 19y's, equal to 114. And let's see, I'm guessing it probably goes in maybe 6 times. That seems reasonable. 19 times 6, 9 times 6 is 54. 6 plus 5 makes 11. So that's correct. You can always use a calculator if you get stuck on the division. So y equals 6. Plug it back in. Neither equation is especially nice, but I'm going to go with equation 2. 2x plus 3 times 6 equals 10. 2x plus 18 equals 10. So 2x's equal negative 8, and 1x equals negative 4. Check it. Make sure it really works. Right, we think our answer is negative 4 comma 6. And we're going to check it in the first equation. So that's negative 5 times negative 4 plus 2 times 6 is supposed to equal 32. 20 plus 12 equals 32. That is true, so I know my answer is correct. Once again, you could do this by eliminating the y's. You would multiply the first equation by 3, second equation by negative 2, add it up, and you're going to get your y's to disappear, and you'll solve for x. When you solve for x, you should get negative 4. Then you would plug it back in to your one equation and get y, and you would find that y equals 6. So you'll find that you and your neighbor don't always do the same thing on these kind of problems, but you still end up with the same answer as long as you both did the algebra correctly. We're going to stop there. We will use elimination on some word problems Monday in class, but we're going to hold off for now. So thanks for listening. See you tomorrow morning or afternoon.